Hello, so today's topic is thermodynamical work done. Uh, work done by thermodynamical system. What is thermodynamical system? Generally, we consider it as an enclosed gas. Here, I will consider a cylinder. This is a two-dimensional diagram. That is why you can see it as a rectangle, but it is a cylinder with this movable piston. I have made this with dotted line, which shows piston's initial position, and if we supply some heat to it, it expands, and this is with solid lines. This is its final position. So this is how the gas is expanding, and we will call it as its work done. So we know that work done is force time displacement in the direction of force. So here there will be a force exerted by gas on that piston, but as we know that F upon A is the quantity of our interest. I have divided and multiplied by A, so that F upon A becomes pressure, because this is what we deal with thermodynamical system. We deal with pressure and temperature and volume type of things. Here you can see this portion of delta x displacement, that is a cylindrical portion which has moved up. This is a change in volume. So that is why delta x times A is change in volume, delta V. And we know that PV equal to mu RT. Mu is number of moles there. So P dV will be equal to mu R dt if P is constant. If it is not constant, then we have some other complications there, some other representations there, that is totally calculus based. So in order to keep this thing in our mind, that dw equal to p dv, we can also replace it with mu r dt. Other than that, graphically this work done can be represented by area below PV graph but not directly as we can write a PV graph. In that, it must be bounded with volume axis. So, like, I'll give you few examples of those PV graph. So you can see first one is for isobaric process. Second one is for isochoric process. Third one is for isothermal process, and fourth one for adiabatic process. So you can see. And other than these, there can be any other shape of that PV graph, whatever it is. But ultimately, if we take the area below that graph bounded by volume axis, we can find work done by that thermodynamical process, work done by the system for that thermodynamical process. So, and you can see here in isochoric process, there's no change in volume. It's a straight line and no area under the graph bounded by volume axis. So work done there is 0. And this is what we can understand, that if volume is not changing, then there is no thermodynamical work done. So this is the basics of